Welcome students in this beautiful session of the topic projectile. This topic is from the chapter Motion in a Plane and important for the CBSE NEET as well as the IIT JEE examination. So let's begin. That what is projectile? So a body which moves in a two-dimensional plane in the gravitational field of the earth is called projectile. Now, for example, like a cricket ball thrown by a player, not rolling on the ground, it will be thrown by the hand of the player. Okay, like this. An athletic taking a long jump or a high jump. A bomb drop from an aeroplane flying at the some height. So as you can see there, this all this kind of motion happen in a two plane. Okay, or we can say a plane, or a plane consists two particular axes like x or y. It may be yz, it may be zx. Okay, but this consists of plane actually. For example, like a projectile. As you can see over here, man fired from the cannon and olden days. A body throwing a ball in a projectile motion. Boy throwing a ball in a projectile motion. So there are different kind of projectiles in the nature. So one by one we are going to study. Okay. So we are going to study projectile motion in two separate cases, and normally as a like oblique motion or a oblique projectile motion, and the second one is a horizontal projectile motion. The first case is for the oblique projectile, in which a body projected at an angle theta, where theta is not equals to 90 degree and 0 degree, horizontally and moving only the influence of the gravity, or only the influence of the force of gravity is called as oblique projectile. For example of oblique projectile, a cricket ball thrown by a player. As you can see, this will be a like the player throwing the ball at a particular angle. When we are talking about the athletic, so athlete taking a long jump or a high jump. So taking the trajectory of projectile, okay, which is a parabola. So what we are doing, just throwing a thing and with respect to two axes, okay. The thing is that like theta not equals to the 90 degree, it must be less than 90 degree. So we have a two component of a velocity, like in a horizontal way we have a cos theta, and in a vertical way we have a u sin theta. So at the maximum height, the initial velocity of the object will be zero, and it will be moving from their final velocity, which is under influence of a gravity. We can take as a free fall also at the maximum, from the maximum height. Okay, so now the particle moving, and one component which is a not changing, that is a u cos theta, and the changeable component is a continuously, that is a v, or a y component, that is a u sin theta, is a completely changed. So at maximum height 2 till initial to the till final, one component remains same, that is a u cos theta. So from point, what is r over here? That is the completely range which is covered by the particle. So this is the velocity component which responsible for the trajectory of the projectile for the parabola. Moving ahead, consider a projected into a air, a body which is projected into the air with an initial velocity. So what we are going to take? A body. We are just doing projected that body into air. Okay. Initially velocity u. So this will be initial velocity, and we are making an angle theta. which is less than 90 degree. Okay, keep in mind. Initial velocity, you can be resolved into two rectangular component. Okay, so the two rectangular component is what? One is a like vertical component, and second one is horizontal component. Horizontal motion with zero acceleration is u cos theta. So we have, as you know, we have two types of component. For x, the responsible component ux is equals to u cos theta. And as I told you, vertical component, we have also uy is equals to u sin theta. So this is a horizontal component, and the next which we remains the constant throughout the journey, and vertical motion of with the constant downward direction. So this is a vertical motion with a constant downward acceleration because the particle initial velocity will be u by which we thrown the body, but returning back where the speed is actually where the velocity actually changes and particles start to move under influence of a gravity. From there, uy is equals to u sin theta is continuously changes, varies with time. Okay, so let the projectile be at some point like a pxy. After time t x and y, the horizontal and vertical displacement time t along the horizontal direction, horizontal displacement x is equals to u cos theta times t. So t is equals to x by u cos theta. Along the vertical direction, the displacement y is equals to u sin theta t minus half gt square. So what we will going to do, like substituting all these value here. So after substitution, oh, okay. So after substitution, what we get, like y is equals to u sin theta. In the place of a t, what the value we know, that is x by u cos theta. Similarly, we will put here y is equals to tan theta because sin theta by cos theta from basic that we know, sin theta by cos theta gives the value tan theta. So like u sin theta by u sin theta x by u cos theta, so u will be cancelled out and we get this value tan theta times x minus g by 2u square cos square theta. Okay, which is the equation of this, like y is equals to ax minus bx square. So this is the equation for a parabola. The trajectory of the projectile is a parabola. So where a and b are constant, like a is equals to tan theta and b is equals to g by u square cos square theta. Now move with some multiple choice question part. A body which moves in two-dimensional plane in the gravitational field of the earth is called a horizontal path, vertical path, hyperbola, or a projectile. So students, the correct answer for this question is a projectile. Next, a body projected at an angle theta horizontally and moving only under influence of the gravity. Okay, influence of the force of a gravity is called horizontal projectile, oblique projectile, only projectile, and both A and C. So the correct answer for this question is oblique projectile. Now for the oblique projectile, we have one more topic like a maximum height of the projectile. So for maximum height of the projectile, what is the mean of that? The maximum vertical distance traveled by the projectile, or we can say where the initial component of the velocity vector becomes 0. Okay, before its vertical component of the velocity becomes 0. So vertical component of the velocity becomes, so that is called maximum height. along the vertical direction. Initial velocity uy is equals to u sine theta. Final velocity vy is equals to 0. Acceleration ay is equals to minus of a g. So distance traveled s is equals to h. So from v square minus u square is equals to 2as, we can say 0 is equals to u square sine square theta is equals to minus 2gh. And h is equals to u square sine square theta by 2g. At the maximum height, velocity of the projectile is u cos theta along the horizontal path. And at the maximum height, the acceleration of the projected body is equals to the acceleration due to the gravity acts vertically downward. As you can see, student, here I had taken the value of g is a plus, because when we throw the body upward, we are doing we are doing the acceleration towards we are doing the work against the gravity. Okay, like a gravity wants to attract the body towards that the center, and when the ball, like ball is a, I just thrown the ball upward. So in this particular process, acceleration, the direction of acceleration due to gravity is in the opposite direction, but at the maximum height, when the body start to falls, so it will be false at the downward direction. So the direction of a gravity in this direction is also in same. That's why we have taken positive sign. So at the maximum height, the angle between velocity and acceleration of the projectile is 90 degree. And the time of ascent, we have a two time. Like time of ascent means when the particle reaches its maximum height, and descent is when the reaches its ground. And complete time is called as time of flight. Again, the particle reaches its maximum height takes up time, that is the time of ascent, and from the maximum height it will be reached at the ground, that we call time at descent. Complete time interval from the initial to the final is called as time of flight. So that the time taken to reach the maximum height is called the time of ascent. Okay, so let the time, okay, be denoted by the TA. What is the mean of T? Ends in the subscript, as you can say A. A means ascent. Okay, at the maximum height, the velocity of the vertical component will be 0. That means Vy is equals to 0. And from this equation, we can say Vy is equals to u sine theta minus dt. So here Ta is equals to u sine theta by g. This is the equation A. So time of flight, that means total time of the projectile takes to reach the same horizontal plane of the projection is called the time of flight. This can be obtained by substituting y is equals to 0 and time t is equals to capital T. So we can say 2 times of a t, or t1 plus t2, time of ascent plus time of a descent will be total time interval. Now moving ahead, y is equals to u sine theta t times minus half gt square is equals to 0. So t is equals to 2 u sine theta by g is in option B. Comparing equation A and B, we get t is equals to 2 times of a ta. Y is the time of flight double the time taken to the reach maximum height of a projectile. It is due to the symmetry of the parabola path. So few points we have to note it down, which is a very important, the time of flight and time of ascent and the time of descent. Okay, so as I told you, what is the time of descent, students? Time of descent, it is the time where the particle reaches from the maximum height to the ground. Okay, with that, t is equals to u sin theta by g plus 2u sin theta by u sin theta by g. This comes to u sin theta by g. For the horizontal range of a projectile, the maximum horizontal distance traveled by a projectile from the point of projection during the time of flight is called as horizontal range. Along the horizontal range, initial velocity ux is equals to u cos theta, acceleration ax is equals to 0, distance traveled by s is equals to r, and time taken t is equals to t. From s is equals to ut plus half at square, we can say that r is equals to u cos theta times a t. But t is equals to 2u sin theta by g. So what we are going to do, we just put the, see, we get the time, okay, we get the value of r, which is a u, okay, r is nothing but ut. So what I did, I just put the value of t and u. So horizontal will be like u cos theta. After substituting all this part, we get 2u square cos theta sin theta, 2 sin theta into cos theta. We know that the formula 2 sin theta into cos theta, this will be sine 2 theta. Okay. So since 2 sin theta into cos theta is equals to sine 2 theta, so we will get the value to, we will get this value r like u square sine square 2 theta sine 2 theta by g. This is the value of maximum or range covered by, horizontal range covered by the particle. What we have to do, note, for a given value of projection velocity u, r is the maximum when 2 theta is equals to 90 degree. That is theta is equals to 45 degrees. So maximum horizontal range is nothing but r max is equals to u square by g. Since sine theta is equals to 1, sine 90 is equals to 1, so for that, for a given speed of projection u, the ranges are equal for angles. Like 90 minus theta as you can see. So the maximum angle should be less than 90. Okay. So theta can be 90 theta or 90 minus theta. 45 plus theta or 45 minus theta. Velocity of the projectile at a particular instant of a time. It's a very important question for the IIT purpose, not for the 11th purpose students, because what we are doing in the CBSE boards, in CBSE board we are taking the particular things by the formula wise, okay, concept wise plus formula wise. But in the IIT JEE examination, we know the core basic of a knowledge where we get mix up questions, so we can solve it now. The horizontal component of the projectile remains constant all the time because acceleration due to gravity has a no component, and along the horizontal, like a horizontal component of the velocity after any time t is vx is equals to ux, which is equals to u cos theta. So vertical component of a velocity after any time t is vy is equals to uy minus gt. So from here we can calculate the value of a vector v, which is a u cos theta I cap plus u sin theta minus gt j cap. And then the magnitude of resultant velocity we can calculate by vx square plus vy square, which comes u square cos square theta plus u sin theta minus gt whole square. So after solving a bit, we get the value of alpha, that tan inverse vy by vx at any instant of a time means we can calculate the direction of a velocity vector also, which is get the value of alpha. At any vertical displacement, we get the velocity like a vector v is equals to u cos theta I cap plus under root of u square sine square theta minus 2gh j cap. So the important point which we must be know that horizontal component of the velocity remains constant since acceleration due to gravity has a no component along the horizontal in this case. Second point which we have to memorize, like prepared, the vertical component of the velocity goes on decreasing during the ascent and goes on increasing during the descent. Becomes zero at the highest point. Third point, which is important for the noted down, the thus velocity of the projectile is a maximum at projection point, like equals to u. Velocity of the projectile is a minimum at the highest point equals to u cos theta. Again, velocity of the projectile is a maximum where the projection point is to u, and velocity of the projectile motion is a minimum at the highest point. Change in velocity of the projectile is equals to the u sine theta. So finally, we can say change in Vy is equals to Vf minus Vi. That is u sine theta minus u sine theta. So we have a u 2u sine theta and Vx is equals to 0. Similarly, the main thing is that similarly momentum is also 2 mu sine theta, and average velocity of the projectile during the entire journey will be total displacement by time, range by time of flight, and angle between the velocity and acceleration of the projectile is between 90 degree to 180 degree during the ascent, that is the dot product of velocity and acceleration is negative during the ascent and is between 0 degree to 90 degree during the descent. So as you can see student, between 90 to 80 during ascent, dot product of the velocity and acceleration is take place, and that will be the negative. And between 0 to 90 degree during the descent, that is a dot product of the velocity, positive during the descent. Okay, is a 90 degree at highest point, that is the dot product of the velocity and acceleration is 0 at the highest point. The thing is which we have to note it down, at the projection point the total energy E total is equals to half mvu square, and that is it is purely kinetic. Noted down that the next thing also, at the highest point of the projectile, kinetic energy Ek is equals to half mvu square cos square theta, which is E total cos square theta. Potential energy Ep is equals to half mvu square sin square theta, which is equals to E total sin square theta. Ratio of the potential to the kinetic energy Ep by Ek is equals to tan square theta. If t is the time of flight of the projectile, then maximum height. So at the projection point, in the complete study, what you get, like pure energy will be energy will be purely kinetic. Okay, during the projection at the highest point, kinetic energy becomes like Ek is equals to half mvu square cos square theta. So E total will be E total will be cos square theta. Potential energy will be E total sin square theta, and the ratio will be get tan square theta. So if the time of flight of a projection or a projectile is at the maximum height, if anybody asks like what is that, so maximum height at time t, the maximum height is a 1 by 8 times of a gt square. We know that t is equals to 2u sine theta by g, so we get u is equals to gt by 2 sine theta. So h is equals to u square sin square theta by 2g. After solving, we get this value 1 by 8 t square, gt square. From here, we can think one thing more, like for a projectile, angle of projection theta, range r, and the maximum height are related as tan theta is equals to 4h by r. Maximum height is u square sin square theta by g, and range will be u square sin 2 theta by g. So equation 1 by equation 2, we when we solve, we get this value tan theta by 4 is equals to h by r. That means tan theta is equals to 4h by r. The time of flight like t, range r, and the projection time t is related. Gt square is equals to 2r tan theta, where t is equals to 2u sin theta by g and r is equals to 2u square sin 2 theta by g. Okay, and if I'm talking about the next first first equation, I'm squaring divide by 2, we get this relation again, like 4u square sin square theta by g. So g we can cancel out from here, Okay, u square also cancel out from here. Sine 2, yeah, here this will be u 4 u square sine square theta. Sine 2 theta we can write as a sine 2 sine theta into cos theta. Now, here the sine theta is remaining and here the cos. So, 2 we can and the u square we can divide. This comes 2 tan theta divided by g and is equals to t square by r. That means gt square by r. gt square by r is equals to 2 tan theta, or gt square is equals to 2r tan theta. R tan theta is equals to 4h is equals to half gt square. Range of the projectile is a maximum when angle of the projection is a 45 degree. R is equals to u square sine 2 theta by g. So R is a maximum if sine 2 theta is the maximum. That is, if 2 theta is equals to 90 degree or theta is equals to 45 degree, in this case, we can easily find out the value of a range. Another thing. One thing which we have to note it down more, like the range of projectile, maximum height if theta is equals to tan inverse 4 or 76 degree. We know that tan theta is equals to 4h by r. So r is equals to h. Tan theta is equals to 4. And for this, tan inverse 4 is comes 76 degree. For projectile, in the case of complementary angles, like the range is same. So if theta and 90 minus theta angle are of the projection, we have R1 is equals to u square sine 2 theta by g and R2 is equals to u sine 2 theta, that means 90 minus theta by g. So R1 we can get like u square sine 2 theta by g and R2 we can get like sine u square sine 180 minus 2 theta by g. From here we can say u square sine 2 theta by g is nothing but R1 is equals to R2. So if H1, H2 are a maximum height, so H1 plus H2 is equals to u square by 2g. And we have H1 is equals to u square sine square theta by 2g. And H2 is equals to u square sine square theta, sine square 90 minus theta actually by 2g, which is equals to u square cos square theta by 2g. So when we accumulate all these values like H1 plus H2, this comes u square sine square theta by 2g plus u square cos square theta by 2g. Now we can do common like u square. So what we get? Sine square theta plus cos square theta. And from the basic we know sine square theta plus cos square theta is comes 1. So in the place of a sine square theta plus cos square theta, we can directly put the value 1 and get the value R1 is equals to R2, which comes is equals to R 4 times under root H1 H2. And from here H1 plus H2 is equals to 2 u square by 2g. So if T1 and T2 are time of flight, so T1, T2 is equals to 2R by g. Okay. The C1 solution we have like T1 is equals to 2 u sine theta by g and T2 is equals to 2 u sine 90 minus theta by g. In this case T1 T2 that means 4 u square cos sine theta, sorry, 4 u square sine theta cos theta by g square. We know to sine theta into cos theta is equals to sine 2 theta. So we can write as a 2 here, 2 into 2 and 2 I'll just take in from this sine 2 theta by g square. Okay, so u square sine, we know that. This will be the value of r, so we can say T1 T2 is nothing but 2g by r. Okay, so as I told you T1 T2 is equals to 2r by g. So r is equals to 1 by 2 g times of a T1 T2. Here the point which we have to note that if horizontal and vertical displacement of the projectile are respectively x is equals to at and y is equals to bt minus ct square, then velocity of the projection u is equals to under root of a square plus b square, and angle of projection theta is equals to tan inverse b by a. Note the point, like for a projectile, y component of velocity at half of the maximum height is equals to u sine theta by root 2. And proof which we have to do, like applying v square minus u square is equals to 2as. For upward journey of a projectile, we have u sine theta, u is equals to u sine theta, and a is equals to minus of a g. S is equals to half of h, and S is equals to half of, the value of h is, we know, u square sine square theta by 2g. So substituting all these value, and we get v square is equals to u sine theta whole square minus u square sine square theta by 2. How we will get, like v is equals to, we know, student, v square we know, and u in the place of a u square, so the vertical component will be u sine theta. That's why we put this value minus half. Okay, this will be g and t. So we know like half gt square. So in the place of a g, this will be minus of a like g. So I'll just put g. Okay, and in the place of as I told you t, what we have, a 2 square sine square theta by 2g. Okay, so g will be cancelled out from here, and yes, of course, like wait, for the case of a g, this will be u square sine square theta by g. Okay, and this will be minus with the half of a t. So t will be, as I put this value, g will be cancelled out, and we got this value. I hope there will be no issue for that. If there is, so you may ask in the chat session or in the comment section. Now v is equals to u sine theta by root 2. We can get from here velocity of the projectile at half of the maximum height. We can write in this form also, like a v is equals to u times 1 plus cos square theta by 2. We have a proof, like velocity at a particular instant, we know v is equals to under root vx square plus vy square. But we know vx is equals to ux, which is equals to u cos theta at any point, while vy is equals to u sin theta by root 2. At half of maximum height, v is equals to under root of u cos theta square plus u sin theta by root 2 ka whole square. Now simplify, and we get the value of v, which is equals to u times under root of 1 plus cos square theta by 2. The thing which we have to note it down, the path of a projectile as seen from another projectile, x1 is equals to u1 cos theta 1 t, and y1 is equals to u1 sin theta 1 times t minus half gt square. x2 is equals to u2 cos theta 2 times t, y2 is equals to u2 sin theta 2 times t minus half gt square. Delta x is equals to u1 cos theta 1 minus u2 cos theta 2 times t. And delta y is equals to u1 sin theta 1 minus u2 sin theta 2 times t. So delta y by delta x comes u1 sin theta 1 minus u2 sin theta 2 divided by the value of a delta x, as you can see here. So u1 cos theta 1 minus u2 cos theta 2. After division, if u1 sin theta 1 is equals to u2 sin theta 2, the value comes like initial velocity becomes r equals to the final, then slope will be 0. And the path of the projectile will be only horizontal, and we can see straight line. Second situation, if u1 cos theta 1 is equals to u2 cos theta 2, initial velocity is equals to the slope will be infinite. The path is a vertically straight line, and before that is a horizontally straight line. If u1 sin theta 1 is greater than u2 sin theta 2, in this case u1 cos theta 1 greater than u2 cos theta 2, the path of the straight line will be positive slope. And in the case of a less than, like u1 sin theta 1 is greater than u2 sin theta 2, but u1 sin theta 1 is less than u2 sin theta 2, or u1 sin theta 1 is less than u2 sin theta 2, and u1 sin theta 1 is u1 cos theta 1 is greater than u2 cos theta 2. In this case, the path is a straight line with the negative slope. The thing which we have to note it down, students, it's an important point. A body is projected up with a velocity u at any angle theta to the horizontal from the tower of a height as shown. It is clear that such body also traces the parabolic path. Okay, the time t to reach the ground arrived as to explain below. The component of the velocity as shown, this is a kind of a horizontally projection. So the responsible factor will be u cos theta, and as you can see u sin theta also. So resultant will be only u. Here the body can treated as a body projected vertically upward with a velocity u sin theta from a tower of a height. Hence the equation of motion on reaching the foot tower is h is equals to minus u sin theta times the t plus half gt square. By using formula for a height of tower, we have to note that a body is projected down with a velocity u at an angle theta to a horizontal from a tower of a height h as shown. It is clear that such a body traces a parabolic path. The time taken to reach the ground is arrived as explained below. The component of the velocity are as shown. Here the body can be treated as a body projected vertically down with a velocity u sin theta from a tower height of height h. Hence the equation of motion on reaching the foot of the tower is h is equals to u sin theta times the t plus half gt square. Using s is equals to ut plus half gt square, where u is equals to u sin theta. So a body is projected with a velocity u at an angle theta to a horizontal radius of a curvature of a trajectory when the velocity vector makes an angle alpha with horizontal. So let v be the velocity of a body when it makes an angle alpha with the horizontal. Then v cos alpha is equals to u cos theta, or v is equals to u cos theta by u cos alpha. Cos alpha. It is clear that g cos alpha, u cos alpha plays an important role for the radial component. Like how much the angle of changement in the angle, or how much the body will be projectile actually, the responsible factor will be g cos alpha. So g cos alpha is equals to v square by r, or r is equals to v square by g cos alpha. R is equals to the value of g, the value of cos alpha, u cos theta by cos alpha times whole square divided by 1 by g cos alpha. So this comes u square cos square theta by g cos cube alpha. When projected is at highest point, it is clear that alpha is equals to 0. In this case, r is equals to u square cos square theta by g. For projectile motion with an velocity u at an angle theta to the horizontal, find the magnitude of a torque about the horizontal when it strikes the ground. We know that torque tau is equals to force into perpendicular distance from the origin on to the line of action of force, mg into range, mg into u square sine 2 theta by g. Now let's move with some multiple choice question, student. We covered already maximum conceptual part. Now we are going with the questions. Maximum height of a projectile. H is equals to u square sine theta by 2g. H is equals to u square cos theta by 2g. Or H is equals to u square sine square theta by 2g. And the last one is H is equals to u square sine theta by g. The correct answer for this question is option C. Moving with the next question. At the maximum height, angle between the velocity and acceleration of the projectile is pi by 2, pi by 4, or pi by 8. The correct answer is a pi by 2. Equation for trajectory of a projectile. This is a horizontal projectile, and for the case of a horizontal projectile, we can see, okay, the equation for path trajectory. So the particle throwing from the tower of a h height. So let us consider a body of a projectile horizontally with a initial velocity u from the top of a building at height small h. The body travels in both horizontal and vertical directions simultaneously. It reaches the ground because of a no horizontal acceleration. The horizontal velocity remains constant throughout the motion. Hence, after time t, the velocity in horizontal direction will be Vx is equals to u. The initial vertical velocity at time of a projection is 0, that is uy is equals to 0. There is an acceleration g along the negative y direction. The vertical component of velocity goes on increasing. Let the body be at point P after time t. X and y are horizontal and vertical displacement after time. Along horizontal direction, x is equals to ut, which is a t is equals to x by u. And along vertical direction, initial velocity u is equals to 0. Acceleration a is equals to plus g and displacement s is equals to y. Time taken t is equals to t. So from s is equals to ut plus half at square, y is equals to half gt square, which is the second equation. Now substituting equation 1 into y is equals to half gt g x by u whole square. So y is equals to half g x square by u square. From here we can say g by 2u square is equals to in times x square. So let g by 2u square is equals to k. So y we get k times of x square. And this is the equation of representation parabola. So what is the difference between the before and after one? Like in the before projectile case, oblique projectile case, we will get the displacement equation in the terms of a theta. But here as you can see that there is a no theta term will be present over here. Hence the trajectory is a parabola. And time of a descent, the time taken by the body to reach the ground from the maximum height is called as a time of descent. Along the vertical direction, initial velocity uy is equals to 0 and acceleration ay is equals to plus of g, displacement s is equals to h, and time we have taken t. So from the second equation of motion, s is equals to ut plus half at square, h is equals to half gt square, and t is equal Td is equals to under root 2h by g. Range, the maximum horizontal distance traveled by the body while it touches the ground is called range. And as the horizontal velocity is a constant, so the range will be horizontal velocity into time. That means u into t. And t we know 2h by g. So r is equals to u times of under root 2h by g. Third, velocity of the projectile at any time t, we get a body be a point P after a time t. Let Vx and Vy will be the velocities along x and y direction. The horizontal velocity remains constant throughout the motion. Hence, Vx is equals to u, and the velocity along the y-axis is Vy is equals to uy plus gt. But uy is equals to 0. So Vy is equals to gt we have. So the magnitude of the velocity, that v is equals to vx square plus vy square is equals to u square plus g square t square with the root. If velocity vector v makes an angle alpha with the horizontal, then the tan alpha is equals to vy by vx is equals to gt by u, or alpha is equals to tan inverse gt by u. Application first, a body is projected horizontally from the top of the tower. The line joining the point of the projection and striking the point make an angle 45 with the ground. So that case h is equals to r. So half gt square is equals to ut and t is equals to 2u by g. Application second, which we have the body which projected horizontally from the top of the tower. The line joining of the point of projection and striking point makes an angle 45 degree with the ground. Then displacement will be under root 2 times of r. From this figure, tan 45 degree is equals to 1. 1 is equals to h by r, so that we can say h is equals to r. Displacement AC is equals to under root of AB whole square plus BC whole square. The value of AB, h, and value of BC, h. From here we can put this value and get our result, which is the under root r. So one problem I'm taking as a question, a particle is projected horizontally with the speed u from the top of the inclined plane and making an angle theta with the horizontal. How far from the point of projection will the particle strike the plane? So the range we have to ask a range formula we know under root x square plus y square. What is the x and y? So these are the plane's axis, okay, coordinate axis. So y by x is equals to tan theta. X is equals to x, like y is equals to x tan theta. So we put this value, we know the value of under root 1 plus tan square theta. This will be sec square theta. So with the root, this will be sec theta, okay. So x is equals to ut. That means y is equals to half gt square. Y by x is equals to half gt square by ut. So tan theta is equals to gt by u, or t is equals to 2u by g times tan theta. X is equals to ut, so we can calculate the value of x also, which is a 2u square by g tan theta. Similarly, we can find out the range also, which is a 2u square by g tan theta times a sec theta. Projectile motion on an inclined plane. So let a particle be projected with a speed u from inclined plane makes an angle alpha with the horizontal velocity of a projection makes an angle theta. With the inclined plane, we have taken reference x-axis in the direction of plane. Hence, the component of initial velocity parallel and perpendicular to the plane and are equals to the u cos theta and u sin theta respectively. That is, u parallel is equals to u perpendicular and u perpendicular is equals to u sin theta. The component of g along the plane is g sin alpha and perpendicular to the plane g cos alpha as shown in the diagram. So when we put this value, we can calculate the value of a time of flight also. We know oblique time of flight t is equals to 2u sin theta by g. So we can say like t is equals to 2, this is a for perpendicular by a perpendicular. I hope this much topic you have understood. Now student, if you have any doubt, any query or any like suggestion you want, so you can ask, like you can put in the comment section. Till that, be join, be like connect with the team of an again group of Digital Learning Institute. Take care everyone, and thank you for watching this video.